If you've ever seen the deep field photograph taken by the Hubble Space Telescope, you know that the universe around us contains many, many galaxies that are invisible to the human eye. The James Webb Space Telescope is an upgrade to the past Hubble telescope, which is set to launch into orbit around the Sun in 2019. Currently, our only deep field telescope in orbit is the Hubble Space Telescope, and this new and improved version will blow its predecessor out of the water. Today, I will be discussing the James Webb Space Telescope itself, how it was an upgrade from the Hubble, and what we hope to learn about the universe with this new technology. The James Webb Space Telescope is the most advanced and largest telescope set to launch into orbit. It is comprised of 18 hexagonal gold and beryllium plated mirrors that create a total of a 6.5 meter diameter mirror for gathering light, which is almost 5 times as big as the Hubble's main mirror. These mirrors allow for the telescope to see in the infrared, due to being cooled by a very impressive solar shield. The only downside to this telescope is that it doesn't see in the visible spectrum as we see with our eyes and as the Hubble Space Telescope does. The solar shield is made up of 4 ultra-thin layers of aluminum and silicon membranes, which cool the telescope to about 50 Kelvin, which turns out to be negative 370 degrees Fahrenheit, which is actually the optimal operational temperature for the telescope. These membranes, which are facing the Earth and Sun, come out to being the size of a tennis court. Since the telescope is so large, the engineers have designed the telescope to fold up like an origami swan and fit inside the cargo hold of a rocket. Once the telescope is set into orbit, it can begin its 14-day unfolding process, which is very delicate. The telescope is set to orbit at Lagrange point 2, which orbits the Sun in perfect synchrony with the Earth. For context, the Moon is about 250,000 miles away, while the orbit point is just short of 1 million miles away. With this distance, it means there is no hope of repairing the telescope if something goes wrong post-launch. Being so far past the Moon and the Earth, it allows for the Earth and the Moon to block the rays of the Sun, as well as avoiding the conflict of shadows to keep the telescope cool enough to operate at optimal performance. Also, by keeping the mirrors of this telescope this cool, it allows for the telescope to view ultra-redshifted objects, which turn out to be further away from us. By being cooler and seeing these redshifted objects, it lets us view a little bit deeper into the universe's past a little bit easier. Now that I've discussed the James Webb Space Telescope itself, I can tell you how it was a bit of an upgrade from our current telescope, the Hubble. For context, the Hubble Space Telescope was set into orbit in 1990 and sits only 340 miles off of Earth's surface, so repair was always possible for the telescope and has been needed to be repaired multiple times. Immediately after launch, the photographs taken by the Hubble were very blurry and could not be made out to see anything. A repair mission was set out, and with the work of the astronauts at NASA, the telescope was repaired. This is something that cannot happen with the James Webb Space Telescope due to it being so far away. As stated before, the James Webb Space Telescope is almost 5 times as big as the Hubble telescope, which allows us a deeper view of the universe. Although being 5 times as big, the ultra-thin materials of the James Webb Telescope allow it to be half the weight of the Hubble Space Telescope, which means it has an easier time getting through the atmosphere as well as drifting to its orbit point. Another thing, new galaxies and planets and stars all form in the middle of very gaseous clouds, which turn to be very hard to view through the visible spectrum. Light gets absorbed by the particles, and we can't see past the particles into the actual formation of the galaxies and stars. However, these new forming galaxies and planets give off infrared radiation, which is actually easily visible by the James Webb Space Telescope. It can be seen, and we can see through these gaseous clouds and into the galaxies that are forming. This will help us uncover more and more mysteries of the universe. Bear with me. Since light takes time to reach us, seeing something 11 billion light years away technically means we're seeing the galaxy or star as it was 11 billion years ago. Since light takes time to reach us, we're not seeing the current composition of it, only its past self. The Hubble can only see to about 13 billion light years away, while the universe is approximately 13.8 billion years old. The James Webb Space Telescope pushes a little further into the past, and we can see approximately 13.4 billion light years away. Now that we can see how the James Webb Space Telescope was an upgrade from the Hubble, I can tell you about what we hope to learn from this new technology. As stated before, seeing into the distant galaxies is analogous to seeing into the past, so seeing further into the cosmos can help us get a better understanding of the very first baby stars and baby galaxies that have never been seen before, and give us a better understanding of how our galaxy came to be. As stated before as well, the Hubble telescope can only see to about 13 billion light years into the past, while the new James Webb, we can see a few hundred million further, which is actually the beginning point of the very first stars and galaxies that ever formed, which is why they improved the Hubble with the new James Webb, so we can see a little bit further to the very first stars that ever formed. Since the James Webb Space Telescope is so sensitive with its onboard spectrometer, if an exoplanet passes through its vision, it can actually detect the composition of the passing planet's atmosphere. The photons passing through the atmosphere bring the actual composition of it to the James Webb Space Telescope itself. This allows us to look for more and more available planets that the humans could survive on in the future. Today, I've discussed the importance of the new James Webb Space Telescope, what the design is like, and how it was an upgrade from our current telescope. Also, what the James Webb Space Telescope hopes to bring to the table. Once in orbit around the Sun, hopefully with this knowledge you've absorbed today, you can see how the James Webb Space Telescope is going to be one of the literally largest instruments for space technology, but also one of the most important. We're going to be seeing galaxies and stars we have yet to ever see before, and we're not sure how it's going to work out, but we know it's going to be good, and you can be sure the entire scientific world will be buzzing about it. Thank you.